Hello, hi everyone. My name is Mohammed Topçu. Welcome to our event called Creating Web Test Automation with Python Behave. I would like to first talk about myself. I'm Mohammed Topçu and I'm working at Kloya as a test automation engineer and consultant for approximately 2 years. I am familiar with test automation frameworks in the different fields like web UI and mobile and API testing. And I am familiar with frameworks such as Appium, Selenium, and Karate framework. Kloya is a solution provider in the areas of DevOps, DevSecOps, cloud, microservices, and software testing fields. We have expertise in this areas, and we are within 4 nominated AWS partners globally for modernization projects and several ongoing modernization projects currently. And we have customers from all around the globe, such as USA, UK, United Arab Emirates, like Germany, Europe, so on. And in this today's agenda, I will give a brief introduction to behavior-driven development, and we will together set up a Python Behave project for web automation. And I will give a brief introduction to page object model and how can we utilize this approach to our web automation projects. And we will write feature files in BDD format with Gherkin syntax to describe our test scenarios in natural English language, or if you prefer, you can use your mother tongue. And also, we will be implementing step definitions in Python for test execution. Actually, there will be some abstraction upon abstraction. Then we will write our codes, and all of them will be handled in the session, and we will find out how to manage test data and how to handle dynamic elements in the session as well. Now I would like to give a brief explanation about what BDD is and why do we need BDD in our projects. It's not just for test automation, but you can use it for different projects, software projects. Behavior-driven development is basically an agile software development methodology in which an application is documented and designed around the behavior a user expects to experience when interacting with it. This actually enables us to simplify the behavior that our software should show us, and whether it is actually behaves as expected or not. And this is actually an abstraction layer upon our coding. So it actually makes it easy to understand for people who are not have a software background or any coding hands-on experience, whether it is a marketing or IT or executive level of people. Everyone can understand what these steps means and what these test scenarios actually do. And behavior-driven development basically enables everyone to understand what these tests are going to do and how the application should behave in certain conditions. Let's look at a simple BDD scenario, and in a feature file. Feature files are actually the scenarios that we should implement in our programming code. And after these feature file are implemented, then we will start to write our steps. Like in here, you can see that this scenario is a part of the feature. Feature is actually a bigger scale of the scenarios, consists of different kind of scenarios here. And these scenarios also consist of some steps in here, as you can see, which are described in plain English. And after writing a scenario, in this example, as you can see, it is a logging in with a registered user to a website. And to log in, what should this application, how this application should behave, we describe it with these steps, like the given, like the given, when, and, then, and but keywords. These are actually do not have any concrete meanings. Like it does not affect the code at all, but it's for the understanding, for people to understand better what these conditions states are. We use given in here as the steps that should be given in these scenarios. Like it should be like this. If you have some conditions that it should be like this for the scenario to start, you use this given syntax. And here you can see that when syntax is actually an action for that specific scenario to trigger it, and the actual condition for the scenario to happen, you describe it when. And these ands and buts keywords are actually the concatenate these scenarios. Like if you have different or a long, when, or then, or given prefixed scenarios, you can use these ands and buts syntax here, so that it can be understood more clearly. And finally, the then syntax is used to describe if a condition, if the condition for this scenario to be passed is defined or not. It will be defined with the then syntax here. This is the simple feature and scenario out example here, and we will be trying to create our own scenarios in this session. So I tried to give you an example what you should expect from this BDD formatted writings. So we will be going to create a project first to implement this BDD. Now I'm going to, let me open a project. Sorry. Now you should be able to see a new project here. And I am using a PyCharm IDE. It's like a text editor. And let's create our project as Python event named. Okay. I am using two windows, so it's sometimes hard. And for you to see clearly, I will remove myself. I get there was a problem with the microphone. Sorry. I will briefly explain what I have what I have done. Now we created a feature file, and inside of it a tests folder, and inside of it a feature file. This feature file is actually the scenarios that we are implementing, and these feature files for these feature files to be recognized, we should install the plugin from this IDE, and here you can write a Gherkin inside the plugin settings, and you should install this plugin for your IDE to or text editor, or if you are using not PyCharm but Visual Studio Code, it should have this Gherkin plugin as well. You can install, and then your IDE should be recognize these files. These files basically feature basically these scenarios are these files actually consists the scenarios that we are writing. You first start with the feature keyword, and you can write here a general definition of your feature. Let's say behave to features, and inside of it you create scenarios here, and these scenarios also should have a name, because when you are executing these scenarios, everything is logged with that particular name. Let's say the example 1 for now, and it enables us to actually give some brief explanations about the feature file, such as this is about the means that Behave provides with us, and this is actually can be used to write general descriptions about these features. And inside of scenario, you can also write scenario specific details here. It think about the scenario as a keyword here. Rather, we can write description too, like that. And inside of the scenario, we can define our scenarios with the steps that we are going to define. First, I would like to show you that Behave can provide us different kind of means to give some data to our scenarios, such as, let's say that when send a specific data to your step. This is our first step, and as you can see, it is outlined, highlighted with a yellow warning that says it is not implemented yet. So when we click on it with right click and show context actions, there is an option that creates step definition. Here it says that what should the file name be and where should the file location be, and I will write it like behave steps. This is the file name, and I want it to be under the features folder inside of a steps folder. As you can see, it is created in here, and it is inside of the behave steps. And here we can see the behave that we have installed in the requirements text is imported, and it says that it will use a regular expression step matcher. This I will cover shortly. And it gives a step definition here that we have written just before. And it actually the implementation of the step. I mean, when you use this kind of abstraction, what should these steps do? It will be written inside of here. Now, what I'm trying to show you here is when you write under of that step a data such as a string. Let's say data is successfully printed. This is actually carried out to this step definition via this context variable. This context variable is specific variable for behave, and it can be reached from step definitions and hooks that behave provides us. I will also cover the hooks and what they are usage of shortly. It can be used to pass variables between different files and these hooks and step definitions. Now the context gives us this text that we have provided here with context.text variable. Now I can use this context.text to create my own context-related variable, like attribute of context variable. How can I achieve that? I can create my own variable with context.myText, and by make them assign to this text to my own custom variable. And I can reach these my text as well from a different step. Like when I write here, let's say I need to verify if it is successfully printed or not, the data that I am trying to import. I can create a step definition, like then print the data using context variable. As you can see, it is not implemented. Every new scenario steps that you are creating will be like this. You should implement them like with the help of your IDE, or you can go to the behave steps, the steps file that you think it should be reside in, and you can write it down manually if you want it so. But it's easier to create it like this. And after you create a step definition file, it also gives option like you should implement it in this file, or if you want to create a new file. Now I will implement it in this file as well. And now I can write a simple Python code block here, code line, to print out my custom text with the variable that I have defined before, like my text. Now, for this scenario to be run, you can see that this option here, and if you click on this one, it runs the specific scenario. If you click on the feature, it runs all the scenario that you have implemented so far inside of that feature. Now let's try if it works. Now, as you can see in the console, we can see that data is successfully printed, which I have sent via behave using its step definition tools. And this is the first basic scenario that we can create with behave. We haven't used Selenium or web browser, WebDriver yet. It is just pure behave and Python, And this is just to show you how behaviors and what's the means of the behaviors provides to us so that we can use them to create our web test automation projects. Now another example can be scenario outline. Scenario outline is used if you have different kind of data sets that you should run that specific scenario with, I mean, every steps of that scenario with just different kind of data. You can use scenario outline. It is written just like this. It is not a different for, let's say, for different data sets. And let's say that we get when step we get data as we have a data and this is a name, and this name variable needs to change every time this scenario executed. So let's say that the then step should be print the data, and these are, as you can see, yellow since we haven't implemented these scenarios steps yet. And here we can write examples. What this example block means is these are inseparable parts of scenario outline. When you use scenario outline, you should use examples. So it gets this custom variable from this example block. So I will, let's say these are example names, and you this long line to create a table, sort of table, and I will write the name of this variable here, which is name, and below I will write Muhammad, Chloe, and Topçu. Now let's implement these scenarios. Okay. Now you can see that they are implemented as default values here. Now I will use the same method to carry out these variable names to different steps. You don't need to use every time like this approach. When you get the name here, you can directly use it from here, but for the sake of the context and how it carries out data throughout the steps, I will use it again, like context dot data equals name. It's basically the data is a custom variable that I assign to context, and it is basically the name that I will get from this table. And then I will use these names to print out with context data again, because it can carry out the name that we are obtaining from previous step to the other step of the same scenario. Now when I run this feature file, you can see that it has executed 3 times with different names, like 1.1, the first name is Muhammad, as you can see, when get data as Muhammad, and it printed data like this. And 1.2, the name was Kloya and printed data as Kloya. So it is basically an important feature of Behave provides, the Gherkin syntax provides to us, so that you don't have to use like a long lines to create for every data specific scenarios. So it becomes much more longer code block. You can just write a simple scenario outline for different examples. I can give you a real world example, such as if you are trying to implement some login related scenarios, test scenarios, and you need to verify for users with different authorizations, like admin user, a guest user, normal user, or super user. You can just create this kind of scenario outline to check all login options with specific credentials for that users. Now, other than that, I can give you another example, like you can call some scenarios. Inside, you can call some steps within some steps. This is another feature of Behave provides us. And let's say that when I call the step on the line line 6, and I will implement this one as well. And here, the context variable gives us a new function called execute steps. And you can write basically a step that you have with the name of, like, when send a specific data to your step here. And it actually finds it from here and executes this step inside of your step. I mean, if you have commonly used steps, like, or some scenarios that is a preliminary part of another scenario, you can use this kind of method, but it is not recommended because the step names can be changed. Like if I change the one here with let's say you deleted this step, and or I'm not sure, but I will try if I refactor if it changed the step definition. I'm not sure. Okay, when I change the step definition with refactor option, it changes this. When I change the step, it changed the step definition as well. But as you can see, the execution steps does not change here, so it might cause some inconsistencies in your project. So it is actually not recommended to use this execute steps option in your projects. So use them carefully. And now I changed this one with manual methods, and let's try to execute this one. And it executed this step line 6 with the step definitions I provided, but it printed out nothing. Why? Because these Did I delete this one? Sorry. This is the data, let's say. Now, as you can see, it does not print out the line here because it is specific to this one. And for this data to be printed out, it also needs this step definition because the actual printing function is defined in here, as you can see. So, but you can see that it is called in this scenario. There are other features that Behave provides, but I don't want to spend more time on it. So let's continue with Selenium and how can we define our WebDriver object. And let's try to create a web project, a web scenario with it. Now I would like to create a driver object. Inside of the feature file, I will create not inside of it, but the main project. I will create a util folder which will include our driver file. Inside of it, we will create our Selenium WebDriver object. Here we can create a driver that we will use in our projects. Let's first start with importing Selenium, which we installed with requirements text file at the start of the session, and we will import WebDriver from Selenium. And to create a specific driver, we need to define options for different ones, such as Chrome, Firefox. So I will create a function, define a function that enables me to create specific drivers. Let's say get driver for this function, and it will get browser and headless options, arguments inside of it. And I will write a match case for this one. If you don't know what match is, it is actually like switch case for Python, which is available after, I think, 3.10 version of Python. So that's it. Let's say that if I want, if I initialize this get driver option with Chrome browser setting, it will do this block. What this block entails is actually creates a browser object, sorry, with the WebDriver which we imported .chrome. And it actually gets some options inside of it, which we can define what this WebDriver would have. And I will mention about it shortly. Let's continue. Then if the case is Firefox, I mean, if you want to create a Firefox browser, now we will write WebDriver.Firefox, and it gets options as well. And if it is a remote Chrome, like if you want to launch your tests in a remote server or a different computer, or if you want to run these on some Docker containers, you can use this remove Chrome option. And for this, there's a different one, like WebDriver dot remote options and options. Now we can end this with return. This function, we can end this with return. What will it will return? The browser object that we have created here. Now, I would like to show you some options, how we can create options and how can we implement them, the definitions of these browsers. Let's create an options variable, and let's make it assigned with Chrome options function. It actually creates an options object and assigns this to options. Now, how can I assign specific options to this empty shell? Here I can write options add argument, like disable pop-up blocking. This actually, the web drivers that Selenium provides actually comes with specific features enabled. So if we want to test a web scenario with all possibilities, we need to configure this web driver so that it shows the thing it shows to different end users. So by disabling pop-up blocking, it actually enables this web driver to show the pop-ups that the web application shows. You can or use like options, add argument, like use fake UI for media stream. And this enables enables the web driver to accept all the pop-ups the web driver shows when you are trying to use camera or microphone. You want to give, it says like you want to give permission for Google Chrome to use your microphone or camera. It actually automatically enables these pop-ups with this argument. But I don't want to write them like this individually, so I will create another function here that adds default options that I provide for every web driver. Like I write them here, and it actually gets the option that I created here. And I also create, I will create a headless function for it as well. So I will write an headless option function here again, so that it can get these options that I am creating customly for every web driver. Let's create the headless one as well. What the headless is, it actually launches your web driver in a headless mode. I mean, you don't see the windows of that web driver on your computer. It executes every steps in the background. It is faster, and less noisy, I can say. And for the headless option, I can write add argument headless. Now, what it does actually, headless option gets the options that we create here and adds argument to it as headless. And also the default options gets options and headless that we give here. And according to their value, if headless is true, it adds headless option here. I mean, it's like a nested thing. And if it is false, it does not add, but just adds the custom and default ones to it. So now I have created these functions. I can just write add default options and headless. So it gets these arguments from here and adds them here, and according to the value of headless, it initializes this function or not. Now I can write them here. Oops. Let me copy them here. Gives an error. I'm trying to find. So it's here. It will be options. Okay. Now we are ready to create initialize our WebDriver, and we can make it through the environment file that is required for behave hooks. So I will create the environment file, and I will talk about what the hooks means and how can we initialize our driver through it. Now, we created our features and scenarios, and Behave provides us some hooks which are initialized before these specific scenarios and after these scenarios executed. Also, you can create some preliminary steps or post steps after these features as well initialized. So the hooks are the basic requirements that you want to do before the scenarios are executed. Now, the first hook is before feature. The other is before scenario. You can define them like this, and it actually, before every feature, runs the code inside of this, and before every scenario, it runs the code below this. So I will import first utils.driver as driver. What I am doing is here that I created a driver file, and inside of it I have a getDriver function so that I import this file so that I can use the function that I have defined to initialize the WebDriver. Now, I just need for before scenario for now, and before scenario, I get a context variable and also the scenario variable. And before every scenario, I initialized our browser and assign this browser to a custom variable that I define here inside the context object as browser. Now, as I have imported the file as a driver, I can write here driver.getDriver. This is the function that I have created. And with what I will create, I can give browser name such as Chrome, and if the headless should be true or not. Now I can write it like this, but giving it a static values are not beneficial, since you might need to use different kind of browsers such as Firefox, or you want to run your tests not in headless mode but normal window. So it is possible to make them changeable with binding them with environmental variables, and thus we are creating a new file called behave-ini. Now inside of this behave-ini file, we write first behave and behave user data. What's the difference of it? Difference of these keywords. These are actually the environmental variables. This is behave specific, I mean the default environmental values, and this is for the user data that we create custom, such as I mentioned, browser and headless options. So inside of this block, I will write browser, let's say Chrome. Now this is a default value, but it can be changed when you are trying to run your driver from the console. And let's write headless here. And here you can write show skipped like these. This is the default environmental variable, and you can write it like false. And this is just the sake of showing that what behave entails with default values. So now, as you will see, we can now get this data from here to here by writing context, which is, as I said, provide from behave context dot config dot user data. Now I can reach that default values from here, and I can write just the key of that environmental variable, which is browser. And now I can do the same thing for here, for headless. Now it gets these data from our ini file, which can be overridden by command line options of behave that provides us, and we can initialize our get driver according to them. If you don't override, then it uses the default values of Chrome and false. And now if I want to start one of these scenario, you will see that did you catch it? I mean, it initialize a browser and it's closed and it shows the data. Now it's as you can see, for every step, let's run this feature file. You will see that for every step, before every scenario, it will initialize a WebDriver, and after that, it runs our steps, and after the scenario ends, it closes the WebDriver. Now, it does not stays open because we didn't actually define any function that uses WebDriver, that drives the WebDriver, but it's just a pure, as I have said earlier, behave and Python option. And when we write different steps that uses Selenium's WebDriver, it will then drive this WebDriver with the functions that we are using. So this environment does what it should do, like before every scenario, create the WebDriver, or you can write here like print, let's write the upper side, like we can say that print scenario has been started with the scenario dot name option. I mean, it provides the scenarios some attributes, scenario related attributes, and we can use them to write it on the console. Let's launch the feature file again. Now, let's look at the example block here. You can see that scenario has been started for different data sets. I mean, it gives the names of these scenarios here for different data sets, the name of that scenario, and it shows that they have been launched successfully before the scenario launches. So this is basically the power of hooks, and you can write it like here. Let's another example after hooks, after scenario. Again, context and scenario, but I'm just going to use this one again. And the scenario has been completed. Now, when I run this, you can see that these scenarios has been started and completed here successfully. And after the scenario has been run, you can see that it gives the data here in the runtime, and it gives the completed log here as we stated. So this is the actual power of the hooks of the Behave provides to us with the environment file. And in the next session, we will be creating a specific scenarios for WebDriver object of the Selenium. This session was to cover all the Behave related features, and we will then concatenate the features of Selenium with the behavior-related ones, and it will be covered in the next session. It will probably take 2 or 3 sessions to create a solid web development project, web test automation project. So if you have any questions right now about these features, these examples, I can answer to them. If you don't have one, I will see you next year. Now I can put myself here. I think there aren't any questions about these features. As I said, we have covered all behavior-related features here. And in the next session, we will cover all the Selenium, the WebDriver objects, etc. And then we can create a more solid project. I have and a question: what would be a good resources to learn about this? I mean, I am a documentary person. Like, I really like to read documents about these frameworks. So the best solution would be first reading that documents, and also we actually have some previous videos that we have created in our previous events. I can send you the channel of our company, and you can see some examples about them. Let me find the link. Here you can see. And also there are some another blog posts. Here is the link of it as well. This is for Ruby specific, but the logic behind it is same, with just different frameworks and different tools, but the logic is the same. It might help you as well. And Orchun has another questions. Thank you, but can we press the buttons during the call? And this is actually for the next session. You can click on the buttons, or you can read the data from the WebDriver web browser. These can be achieved by using Selenium WebDriver. We just implemented it, but didn't use it. For the next session, we will be focusing on WebDriver aspect, and then we will be making many clicking actions, reading or retrieving data, or navigating to different websites. So I can say that you can wait and see in the next session. So I think that's it for this session. I hope it was beneficial for you, and I hope to see you in the next session, which will be probably took place in next year at January. So have a nice New Year, and see you.